Bismillahirrahmanirrahim. Assalamu alaikum. Welcome back to my YouTube channel. And today we would be talking about a really important tool in computational chemistry and especially for organic chemists, which is about conformational analysis of molecules, so that you can have a proper match of the calculated properties with the experimental properties. So, what is conformational analysis and what are conformers? I can give you an example from probably this molecule. So, this is a complex molecule. This is a natural product, and you see that this is one of its shape, and it has many single bonds that can freely rotate. For example, if you look at this one, this single bond, if I rotate it, you will see that the molecule can adopt different shapes. For example, this is one shape which the molecule has adopted now, and similarly, I can rotate any other bond and it can adopt another shape. So these different shapes where I have rotated the bond but not broken and reformed any bond, these are called different conformers of the same molecule. It is essentially the same molecule. It's just existing in a different shape. And when it will be in a different shape, it will have different energy as well. And it will contribute to the properties like NMR, etc., in a different way. So when a molecule is in solution, it's at room temperature, it has these free rotations around the single bonds, and some of them are hindered sometimes, some of them are not. So at room temperature, there are many possible rotations happening in the molecule all the time. So, and whenever we run NMR or some other property of the molecule, it is basically average of all those possible shapes that the molecule is going through in the solution phase. So if we are to model the properties like NMR for this molecule, can we say that if I just take this structure and run optimization and then NMR calculation and match it to the experimental, will it be sufficient or not? That is the question. So the answer is no, because I haven't considered its other possible conformations, and I'm not sure if this one is the energetically lowest one or not. So for this one, I need to do a conformational analysis. And after that, I will have many different conformations, which I can take and then I can submit them for optimization and run NMR calculations. And then if I run the NMR on an average of like I take an average of NMR of all those conformations and match it to the experimental one, it should match nicely. So let's study about the conformational analysis tool. Um Today, I will be showing you about a really nice tool which is called CREST. So CREST, we can write computational chemistry because there are many things named CREST out there. So you may find it difficult to locate the exact CREST. So this is the right CREST, which if you open it, you see this is the CREST computational chemistry and conformational sampling tool. So we will go for its installation. And if you click on installation, then go to step by step. And there are different options, but I like the pre-compiled binaries one, which is just ready to go. You just download it and you can use it simply. So that would be the best one. So I can download from any of these websites. For example, I click on this one. It just started the download and it downloaded it. So I can find it here in downloads. And then I will download another thing as well, which is called xTB. I will say computational chemistry as well. So XTB is a package that is used by uh, CREST. So you need to have the XTB in the same folder as where, like in the same way you should be able to call it as you call CREST. So we will still go for the precompiled binaries. So it says precompiled version can be obtained from this page. And if we come down, you see that I'm downloading it for Windows, sorry, for Linux, because that's easier to use for me. If you want, you can try the Windows one. I didn't try it yet. So this Linux one, the latest one, I'll download it. And now if I check my downloads, I have those CREST and xTB here. So I'll just move them to this test folder I've already made. So what we do now, we will need to extract these. So if I come to the Linux, I will see here are they. So I can simply say tar minus xf crest, and it extracted crest here. Similarly, I will unpack the xtb. So we have the xtb in this binary folder. So now we need to move these two. So I'll simply copy this xtb back here and crest as well, these two files. Oh, did I click copy again? So it tells that there is a folder named crest. We can just say crest1 and then copy it again and paste it. So now I'll delete these two. We don't really need. So these are two binaries which we are going to use. So what I'll do is I'll simply I'll simply copy them, and maybe if I want to copy to my slash bin, it's not possible without doing the sudo, but we can give it a try. So I will copy crest to slash bin. So if you copy it to slash bin, I would of course say permission denied, so I can use the sudo and then do the command. And what will happen is uh, it will copy the crest into your slash bin folder, and similarly you will do the sudo scp xtb. Is it xtbt? No, it's xtb to slash bin. And when you are copied them there, then you can simply call them by crest or xtb, and then you're ready to go. You can simply use them. So what we will do now is if you don't have admin privileges on a Linux, like if you are on a computer where you don't have the admin rights, like a high performance computing system or so, so then you can simply copy to your user slash bin, like slash user slash bin. So that will copy to your bin directory, not the whole bin directory for the system. And that should be possible to do. And when you have done with it, so I have already copied them. So what you can do is you can, let me clear the screen. So you can write crest dash dash version to check that if crest is available, and it will tell you that crest version this is installed. And now we'll check xtb version, and it tells you xtb is also there. So now we have the tools ready, and we simply need to go um, to check like how they work. And it seems like the video has gone quite long, so probably I'll make a second video and stop this one here and make a second part where I can show you how CREST and xTB will work and how your conformational sampling will work. So yeah, stay tuned and watch the next video for that. Thank you and bye.